Hello, everyone. This is Luciano Ramalho. I am the author of Fluent Python. And today I have the honor to interview Naomi Ceder, who is the author of the Quick Python book, third edition. It's now in the third edition, the book. So Naomi, please introduce yourself.
Yeah, hi. I'm Naomi Ceder. As Luciano said, the author of the Quick Python book, and also another live project series from Manning called Explore Python Fundamentals, which is a hands-on sort of project series on Python basics. And I used to be the chair of the Python Software Foundation.
Awesome. Now tell me, what's the format of that
live projects?
Live project, is it video?
It's a combination, actually. It's the live projects started out being sort of a more static series of projects where like you would read the text and then you would solve the problem.
Oh,
but one of the things that we added video. So basically, there are still little groups of projects like explore how variables work by doing these things. But we have demos on video to get people started. And then we go through all of the exercises with at least a version of the possible results. I mean, the idea is people will do their own things, so they might not do exactly the same thing I do, but at least they would have a reference.
Awesome. I really like this idea of project-oriented learning or exploring. In the book, I marked lots of places that I would like to talk to you about. And many of those marks are in the last 3 chapters. So in the last chapters, you talk about they are more project-oriented. What was your favorite project among those?
That's I guess that's kind of a hard one to answer in a way. The thing that I've always sort of done a lot with is the sort of processing files. And I don't know, the whole process of ETL and all of that, it's kind of a boring basic process, except that it holds so many problems and so many possible solutions that
you're right.
Even though it seems like it must be the same thing over and over, it really never is the same thing over and over. If it were, it would be automated and we wouldn't have to think about it anymore. So it is always a different problem.
Exactly. This whole domain of ETL, right? Which is extracting and transforming, and what's the L for? I forgot now.
Yeah, extract, transform, load.
Oh, yeah, load. Yeah, exactly.
Yeah.
You have to take data from somewhere, sometimes reshape it or convert it, right? And then load it somewhere else. It is really a whole class of programs for which Python is extremely well suited, in my opinion. And I really like that part of the book. The next chapter talks about data over the network. So you explain how to use Python to get data from an FTP server, which is something that's still widely used in science, right? Scientists like to exchange. Because they started doing that before the web existed, right? So it's just
true. Well, and it's also kind of a least common denominator. Because even in my current job, there are departments where maybe they're not quite as sophisticated in terms of, responding to APIs and things like that.
Yeah.
But pretty much everybody understands how to do FTP, and all the tools will do some sort of FTP or SFTP. So it's still a pretty common thing.
Yeah, and then you talk about APIs. And data formats like JSON and XML, and then scraping data from the web. I think you use Beautiful Soup, right?
Yeah.
That's kind of that's a neat project that maybe doesn't have an awesome SEO because of the name. I don't know, but it's really awesome. Beautiful Soup.
It is, and it's again something that we use my team at work, and something, I don't know, for many years, it's been the go-to.
And then there's a chapter about saving data, which I really like the name. And it's about databases, and you cover relational databases with Python database API, with SQLite, and then MySQL and Postgres, and then SQL Alchemy, which is cool, and then NoSQL databases, in which you have examples with Redis and MongoDB.
And nowadays, of course, I think both Amazon and Microsoft with Azure have their own flavors of NoSQL databases as well, but they're all pretty similar, yeah.
It's funny because they are similar in some ways, but they are also very different in many ways. So I actually have a slide when I used to talk about NoSQL databases when the topic was trending initially. I had a slide showing 4 cars. Like there was a Cadillac, a Volkswagen Beetle of the old type, what's the name of Isetta? You know, that was one of those tiny cars that only fit 2 people that they did in Europe. And the 4th car is, I forgot. Anyway, the 4th car was like a very low-cost Brazilian sedan. And those 4, so those are cars, all right? So, of course, they are different. There's the Cadillac has certain characteristics. The Isetta is excellent to park, but you won't put it on the road.
Yeah.
But then, so that's kind of comparing without saying which would be which, doesn't matter, but it's sort of the same kind of comparison that you can do with Oracle and Postgres and MySQL and I don't know, maybe Microsoft SQL Server. But then when you look at this at the scenario of NoSQL database, then I have another slide in which I show the lunar rover, one of those vehicles that are, I know, an aircraft tractor that you see in airports, right? A backhoe. So they are all like four-wheeled vehicles, but they are very specialized, and you wouldn't use one for whatever the other one does, right? It just doesn't work.
That's
with
NoSQL
databases, it's kind of like that. Many of them are very specialized, like Redis, for instance. But then MongoDB, in my opinion, is like one of those Volkswagen bus. You know, in Brazil, the Volkswagen bus was extremely popular as a small van for everything, for carrying people and for carrying cargo. You know, there were millions and millions and millions of those in Brazil. And so it's a very versatile thing. It's not excellent in any role, but it's
true.
You know, so MongoDB is somewhat like that. I think it's you won't go too wrong by adopting it, but there's probably for a specific case. That kind of reminds me of a joke about Python that people do, that Python is the second best language for everything.
Yeah, there you go. Right. I think that's fair. I think it's fair with NoSQL databases too. Yeah. I think actually I chose Mongo because it is used for so many things and is popular that way.
Oh yeah.
I think I chose Redis because it's so popular, particularly if your key value store is in memory. It's so popular for caching applications and things like that. So those are a couple of really popular things that were worth mentioning. Yeah,
that's right. Some people use Redis for some kinds of queues also, right?
Yes.
Yeah, and then the last chapter is about exploring data, in which then you go a little bit into the data science ecosystem with pandas and Jupyter, and that's really awesome to have in a Python book, I think, these days. even like this, because this is a very good book to get started. I want to say that to everybody who's listening. I love this book, and I always loved it. I read the first edition, the second edition, and the third edition, and it was always from the start, like 20 years ago almost, a very good first Python book, in my opinion. Well, if not the best at the time. There are other books that people used to read to get started, but they were of a different style.
I've heard from various people that it's the book they used to get started, and they then went on and got like their first job in Python, so things like that. So yeah, that always makes me happy to hear.
No, that's a very good kind of testimonial. Yes, congratulations. You totally deserve it. Then when we were talking about projects, and then the book ends with a pretty good, extensive, right? Like 15 pages of a case study, which is really interesting, about a case study involving parsing data and about weather and so on. There's so much good stuff here. I like very much your approach of covering functions in a part of the book, which is the essentials, you call it. You cover functions very deeply, talking about even non-local and things like that. All the good stuff about parameter passing in Python, which is very flexible. And then you go on to talk about modules and Python programs, and then you have an advanced language features, and that's where you put classes. Can you talk about this idea of putting classes in an advanced language feature?
Yeah, so, it might be partly that I started programming a long time ago, and sort of before objects became all the fashion. So maybe that's part of it. But I think it's also maybe that I spent, I don't know, like 15 years teaching in a high school, teaching programming. And so I had a good chance to see how people learned and what they had struggles with. So when you think about it, you can do a lot with functions, and functions are fairly easy conceptually for people to grasp. I mean, not super, super easy, but if you say, look, you're going to put some of your code in and in effect make a new command, a new thing that you can tell the language to do. Yeah, they get that. There are always things where beginners maybe have some wrong assumptions or whatever, but they get that. They can start doing things, and once you have functions, then you can start making some programs that do quite a few things without confusing yourself. And I remember starting in BASIC back in the 80s, and it was, I think there was a Go sub and you could sort of do functions, but nobody ever did. There was all of these long things. Oh, yeah. Very confusing. So this is a way to manage that. And as I think we've talked about before, I actually did a frequency count on a lot of my everyday code on, what things show up most. And, after if statements and loops and things like that, functions were what I used most for everything. And classes actually were very little. And I think if you look at a lot of people's code, unless they're working on a massive, massive project, if they're working on something that is small to medium size, you're going to be using functions a lot more, unless maybe you learn Java first and where you're told everything had to be a class. Yes. So Java programmers moving to Python use a lot of classes that they don't need to. So it's that's why I would call functions a basic thing and classes an advanced thing. Certainly many good things to be done with classes, not saying you shouldn't use them, but there are many more things that you can do with functions, in my opinion.
Yeah, totally. If if you ask anybody, you can only get one feature. Will it be functions or classes?
Yeah, right.
Well, and in fact, classes can't work without functions, right? Because the methods are functions.
Indeed. I have a lot of fun when I teach people like intermediate Python and we take a bunch of functions in a dictionary and turn it into a class. And if they're new to Python, this is shocking to them. And they're really like, what? I didn't realize it was that simple. But yes, it is.
Yeah.
And I think too, classes are much more complex by nature conceptually because you're not just tracking functionality, you're now tracking functionality and state within that object, which isn't the same as the state of the overall program. Yes. So you're now tracking, in effect, a nested state, which just is hard for beginners. Certainly, if you've done it for a long time, you get better at it. But it's hard to do that and keep track of things. So
that's very true. Yeah, I think one of the things that people are learning is about the limits of classes and the benefits of limiting classes. So, for instance, one of the most successful languages of the 21st century, created in the 21st century, is Go. And Go, well, they do have classes, but they don't call them classes. They call them structs, and they have methods, which to me looks very much like a class. And the struct can have private fields and so on. It's really a class, except that it doesn't support inheritance. Which is a big problem. I think one of the problems of teaching programming in general, and Python also, is to overemphasize classes at first, which is something that unfortunately happens a lot, maybe because of the influence of Java, like you said, or maybe because of some kind of academic bias. I don't know.
Yeah, could be that.
People who like abstractions like to think in terms of categories and subcategories. That's very appealing, but turns out not very useful, right? So I actually have a poster. Yeah, I have a poster in my office of the Java class library. There was an earlier edition and a later edition, but it's very interesting if you look at it because it's really a diagram. The poster is a diagram of the class hierarchy, and it's very shallow. It's actually so shallow that the poster is written in 6 columns. The only parts that are kind of deep in the diagram are the ones that have to do with GUI, which, interestingly, right, this was the setting where Smalltalk was created and all the terms, the idea, the name of the concept of classes and a lot of even the name object-oriented was created by that team. Right?
Yeah, that's a good point, actually. That does make a lot of sense in a way.
I want to ask about your opinion about typing, static typing, because I didn't see anything about static typing in your book, and I'm not criticizing it because of that. I really like the book. I also like very much Dave Beasley's book that came out only a few months ago called Python Distilled, which also does not cover types. What do you think of this new whole area of growth in Python?
I'll start meandering off, but I promise I'll get to the point. I think one of my favorite tweets that Dave Beasley, just to speak of Dave again, recently was that he said that what he didn't like about the way Python was going was the fact that it switched from solving problems with Python to solving problems with Python. That is, we're worried more about the language than we are what we do with the language these days.
About fixing the language. And of course, this is not a video, but I'm doing triple quotes here. Triple quotes.
Right. Yes, absolutely. So it's like, yeah, I mean, I understand that we have a certain number of big enterprise projects now in Python, which maybe we didn't used to have, and they certainly like the idea of having sort of a more typing. And with my team at work, we've got a medium-sized project that we're putting in a few type hints as we go. But I'm not a huge fan of typing. I think there was a recent discussion on the Python dev mailing list where somebody made the point, I do not want to decide features based on whether or not they will make typing easier. This was just in the past couple days, somebody said that. And I was like, I 100% agree. I don't think that static typing should be an essential feature. I don't know that it should decide language features at all. The people who need it will certainly figure out ways to do it, and those tools will continue to develop, and that's fine. But I'm very, very leery of anything that will make people who do not need it have to or feel obligated or whatever to do typing, because I think that is it goes against the readability of the code, honestly. As much as people might say it's wonderful, when you read a function signature and you have to parse out all of the types, that is really intellectual overhead that I don't think we need much of the time. So I'm kind of a slow walker on that.
Yeah. And there's plenty of pathological examples, right? I actually helped fix or improve actually the type hints for the max and min functions built-ins on TypeShed. I found I was studying the subject for my book, and I found a bug report there that the signature of the max function was too permissive, so it was letting bad data get in. Or, well, actually, it's not a runtime check. And the way I said it makes it sound like it. But anyway, it wasn't detecting when somebody was passing a list that could have none inside. And if there's a none inside, then max doesn't work because it has to sort. And none is not comparable with numbers, for example. So that blows up. And when I went to look at it to try and fix it, there were already 3 or 4 lines of overloads. And when I was done with it, which took several days, and I was helped by Ceder Luciano, who is one of the most prolific contributors of TypeShed and typing in general. He helped me a lot. The first PR I made to fix max, or the type hints, had 8 overloads. And Ceder showed me how to simplify it to only 6.
There you go.
And no, that's one very pathological example of a function that's not hard to understand what it does in practice. If you go read the documentation, yeah, okay. And everybody is able to use max very well. I never heard anybody saying that max is super complicated to understand. But with the type hints, it becomes unreadable. But it is a pathological example. Sometimes I do think that the type hints make code easier to read, but that's only when they are very simple, which happens a lot. For instance, in some interesting applications like Fast API and the Pydantic framework that allows you to create little classes that have types that are runtime checked. I think that's neat. The type hints are usually very simple because they are concrete data. There's no reason to be fancy with them, right? And So it's a good use case, but interestingly, it's not a use case that is most concerning to the huge enterprise users of Python. They want the static checking.
Not true.
Right? Because they have millions and millions and millions of lines of code, and whatever they can catch before going to production is going to save them a lot. But they were moving in a direction that was making it harder for Fast API and Pydantic to do their job, to make it easier for the huge enterprise users to use static typing. That was the whole thing about, right? Delayed evaluation of the type hints and so on. It was something that solved the problem that only really huge companies have, because it was affecting performance when starting a system that had type hints. So there was this cost that is really only meaningful if you have a lot of servers, like hundreds of thousands.
Right. Yeah, indeed.
And so, yeah, this is a little bit concerning to me too. I sometimes think that maybe it would be healthier if they came out with a enterprise Python, epython.org. So you have, and then you do their enhancements.
It might eventually happen.
I don't know, because I don't know. The thing is, this is what. Of course, there are other reasons, but it's also a good reason for doing what Microsoft did with TypeScript, right? So this is not JavaScript; it's TypeScript.
I don't know, but yeah. So it is true that leaving out typing was a deliberate choice, because as I thought about people who are coming into the Python world, I just felt, this is not going to be something that they need to deal with right away. Or perhaps if they do, then they're on a team where there will be other means of doing that. So
exactly. Yeah. What I think is the community is very big, right? And it's very diverse. It's actually one of the things that I've always loved about Python, is the diversity of the community in all dimensions. In terms of nationalities, genders, applications, professional domains where people work, right? So if you are an analyst, like a financial analyst that uses Python as a tool, who doesn't put systems in production, then typing is not a great investment of your time, right? It's better to learn pandas better, and learn what other things like that.
Or the people doing, data science or even scientific computing.
Exactly.
They probably aren't worried about that. Yeah.
Yeah. And the kinds of data, because types has to do with data structures in a way, right? The kinds of data that they use is already very well defined, right? It's arrays. Sometimes there are records. And their libraries already provide everything they need to do that, right?
Well, I mean, and it's kind of interesting too, like particularly scientific computing is I don't know, I guess you'd almost say conservative. I've got a good friend, we've been friends since we were children, who's a research physicist. He does things like analyzing gas composition, he's done a lot of climate science and things like that. His tool of choice is still Fortran.
Yes.
I mean, he will use other languages, but if he has the choice,
Another thing that I like in the book, still in the basic part, which, like we were talking, it makes perfect sense, Before you go on inventing classes, which is probably what do people need about classes in Python mostly is knowing how to inherit from a class when the framework requires, right? Like you're doing a Django app, you need to do a subclass of module. But usually I don't think it's a very good idea to come up with your own classes unless you're doing something already, like you said, pretty big.
Right.
Most of the classes you're going to have initially are just something that classes that represent tables, right? in the database, or collections in Mongo, or tables in Postgres using SQL Alchemy.
Right. And I always remind people in that kind of situation, if you write your own class, you then have all of your own bugs to fix. Whereas if you can use a built-in data type, then somebody else is responsible and has probably fixed those bugs.
Because this is something that I always tell people who are getting started with Python. Python is very well done, is extremely high quality, and so as a beginner, it's extremely difficult for you to find a bug in Python, right? Because the paths, the parts of the language that everybody uses are industrial strengths, because they've been refined over decades, right? They are used in very large contexts. But then I like the fact that before teaching classes, you already explain how to create programs, right? Programs, scripts that people will run, and then you show how to run on Unix and Mac and Windows. This is really cool.
Yeah, I mean, I would like to think that if somebody was in a hurry and they only went through the essentials part, they would be able to, in most contexts, they would be able to be productive. They might not be everything, but they would be able to be productive.
Yeah, totally. Yes. It's very good. It's very pragmatic, your approach. I really congratulate you. This is really cool, including distributing Python applications, which is interesting also, right? Because sometimes that's what you need. Sometimes you are in a community, maybe scientists that belong to a certain research community, and somebody comes up with some, somebody creates a program that does ETL of some science data, and you want to distribute that to labs that may use. So this is really very good. You also cover, but then in the advanced language features, which is good, after classes, regular expressions. What's the famous phrase by Jamie Zawinski?
Oh, right. It's sort of like you've got a problem and you want to use regular expressions, and now you have two problems. It's true. It's not the first tool I reach for, but so many times it ends up being maybe the solution after all.
One thing that I think is interesting is to tell people about functions in the Python standard library that you can use instead of regular expressions for certain use cases, right? Which I think Python has a lot. For instance, starts with, ends with are stuff. Those are two simple ones.
Yes.
That in many other languages, people have to use a regular expression to do.
Yeah. The string translate is another one for people cleaning data. Sometimes that can save you a lot of trouble.
Exactly. And I also like your coverage of Python libraries from a user perspective, where you talk about virtual envs and PyPI and pip. Mm-hmm. So what's the story with the cheese shop?
So I mean, I think you've been around Python for a number of years, and so have I. And it was interesting back in the old days. They had a number of libraries and of repositories, I guess, places to get Python code. And like, I think wasn't there like a Starship Python or something like that, and various other things. But then for a while, they were calling the Python package repository the cheese shop, which is, Monty Python jokes are common, but this one, I think a lot of people pointed out, and it always struck me as odd too, because you remember the point of the skit about the cheese shop is there's no cheese in it. So, so maybe it's just as well we moved on.
No, I think it's a great name, because if you think about when it started, there were no, or very few, it was nothing compared with CPAN.
That's right. And that was, I think years ago, I think maybe even in the second edition of this book, I may have said something about how Python has a really good set of libraries and everything. It's not CPAN, but it's still pretty good. And these days, I think I would switch that around. Maybe I didn't say it in the book, but I know I've said it in talks or things like that. And these days, I think it's different. I mean, and that's kind of what's happened, though, hasn't it? Because in the early days, Python always looked at Perl kind of with envy. And Perl was sort of like the mean big brother who sometimes made fun of us and thinking, I remember Larry Wall's like, I'm not worried about Python. And now I think maybe that tables have turned. But
although Larry Wall did bully Guido a little bit in an interview they gave a few years ago, did you see? There was an interview with some language inventors, and they were both there, and Larry was kind of bullying Guido. But yeah, Python took over the world. It's not, I don't think it's meaningful to say whatever language is the number one, because depends on how you count, depends on a lot of things, but it's certainly is a tremendous success. You know, Guido did a tremendous job in the community after him. But I wanna ask you, what do you think is the secret sauce? What caused Python to be so successful?
So I think there are some things related to the language, as we've talked. You and I have talked about this in the past, but I think the fact that Python is kind of centered around an aesthetic idea of how things should look. Beautiful is better than ugly. Regardless of how we define beautiful and ugly, I think that's a powerful thing. And I think, part of beautiful in the Python context is readability, which makes it easier for people to deal with. So, there are technical reasons. I think over the past decade, I think there have been community reasons as well, in that I've had many people say, gee, I know I'm doing whatever language it is. I don't want to mention, but I think for the community, I think I'd rather be doing Python. So I think that's also a driver behind it. I think that's maybe what has led to all of these, like data science picking it up. Well, sure, it's a good language, but maybe there was also, we were more welcoming than other languages as well. So there was that. And, same thing for science. There probably are other languages that would do scientific programming quite well, but we made it very welcoming for people to do that. So I think maybe it takes both. Technical virtues alone, we've seen just the technically superior product fail many times. So that's not in itself. I don't think that's it.
No, the community is always the key, I think, because it's the community that builds the whole ecosystem, right? That makes a language successful. Yeah, I'm also curious about another topic that is also, I don't know. It's one thing is when there's a community that drives a product like Python, which is really community driven. There's the thing about what different groups within that community consider important and right. And so there's and why people consider something important, I think, has a lot of different reasons. Practical reasons are very important, but also sometimes a person is interested in a certain domain, right? Somebody is interested in, like, for instance, Dave Beasley. Dave Beasley is interested in concurrency, right? He loves to talk about that. He's given many talks and tutorials about that. And what do you think of Python's concurrency story these days?
Well, I mean, there's a lot of work, I think, going on now to help it. I mean, it was always in the past the thing where I don't know, when asked to talk about it, I would say all sorts of things like, well, okay, so this is, the way the language is designed, it's not going to change overnight, etc. I think it's become increasingly urgent. I never did think it was an insoluble problem. I think maybe for a while, the community as a whole felt it was an insoluble problem. It was sort of like the 4-minute mile. We're never going to go faster than that, or whatever other impossible problem you want to choose. And I think that maybe kept people from attacking it. I think that I always felt it was just a matter of time until somebody just decided they weren't going to leave it alone, and sort of beat on it until they found something that might work. It seems to me that both the concurrency and the performance story for Python are kind of at that point where we have a number of people who've decided they're not going to leave it alone until they get a better answer. And I think we're already starting to see a few cracks in that problem. So I'm really kind of optimistic now that we're going to see a new generation of Python in the next, certainly within the next 5 years, that will not be our father's Python or whatever, that we'll actually have a better story to tell about that. It always has been in the past. It's one of these things where it's like, you want to do threads? No, you probably don't. Just don't. It was usually my advice for people who wanted to do threads. Unless you're smart enough to have a reason why to out argue me, just don't. But I think that's going to change.
So Mark Shannon, who is, by the way, somebody who is working with speeding up Python, with increasing the performance of the interpreter.
Indeed, he is.
With Guido, their team over there at Microsoft, and he's super smart. I am a big fan of his ideas in Python dev, and he has this PEP called PEP 638 called Syntactic Macros, posted in September of 2020. So if you know about it, can you explain to the people what the feature is, what syntactic macros are, and whether that would be a good idea or not for Python?
I remember that discussion a little bit. I'm not up on the specific details, except that the idea of using macros in a programming language is a way to, what should I say? Basically, depending upon conditions, you actually compile maybe different pieces of code. You actually have different pieces of code based on something you can tell the compiler at runtime, let's say. And I think the basic idea of that PEP, wasn't it to allow language feature changes sort of to be added more easily? To allow people to try things out without going through the painful process of in effect, rewriting a chunk of the code. And I have to admit, as I recall that discussion, it got into the weeds to the point that I think I may have just put it on mute after a while, so I did not follow all the ins and outs of that. But I was really quite attracted to the basic idea, if it can be done without disrupting everything else, having a platform, having a way to make those experiments much, much more easily. It might be opening a Pandora's box, who knows? I mean, you might have all sorts of competing things flying around, but I think that it would be a way to practically handle a lot of the discussions that go on in terms of modifying Python. Somebody says, "Oh, this would be a great idea," and somebody else says, "Oh, that would be a terrible idea." And neither side really has any data to base that on, other than a feeling or a hope.
Totally.
So that's why I would support that. Yeah.
For the listeners who may have not seen, that's not a feature that's very common in languages, syntactic macros, but they would allow people to implement async await in a library. The keywords, not right, not async IO, not the library, but I actually see keywords, and also, for instance, match. The whole match case statement that was introduced recently could have been just a library thing instead of a deep change in the interpreter. Mark suggested that, and then he went into this whole. He got interested in the performance problem, so that there's not been any evolution that I've seen from that PEPs. It was just posted, and there wasn't a whole lot of discussion. But it's an interesting idea.
Yeah, it's still in draft status, I believe. Yeah, I don't think it's been.
All right, so now I think we can wrap it up.
Okay.
Thank you so much, Naomi and Anka, for putting this together.
Thank you.
Really a pleasure.
Subscribe to the GOTO YouTube channel now and join the experts in person or online at any upcoming GOTO conference using the promo code Book Club. Visit gotopia.tech to learn more.